Hello everyone, so in this video we're going to cover section 9.2a, circles in the coordinate plane. So this is going to be hopefully a fairly quick video, but the truth is there's only one thing to this whole section, and it's a formula, okay? So a lot of kids seem to forget this formula, especially when we get to like SAT season, and this is just something that you're going to see often and something that is definitely going to show up on the FSA. So the main thing you need to know is you need to know what is the standard form of a circle. All right, so we've already been talking about circles for a while. We're going to tie back some concepts from the past, like area of a circle, circumference of a circle, and all of that. So really, it all comes down to this one formula. You have x minus h squared plus y minus k squared, and this is equal to r squared. Okay? So the main things to look out for here is you need to know that h and k, let me write that over here. So h and k, that represents the center of the circle. And the thing to make sure that you look out for is the fact that it's minus h and minus k in your standard formula. All right, that's going to really, get some people confused when we start looking about the signs and whether the center is to the left, to the right, or up or down, and so on and so forth. The other main thing that you have to look out for is the r. That's the radius of the circle. So if you have, obviously the center of the circle, that, the h and k is going to tell you where that center is located on a graph. And then that r is going to tell you where it's, how far out to go for the radius. And again, the main thing that kids always mess up here is that you have to understand that what's after the equal sign is r squared. Okay, so a lot of times you're going to see a number here on the outside. You always have to make sure that the radius is the square root of the number, not just the number out there. So we know that r is the radius. But besides that, everything is pretty straightforward. So we're starting off with a simple example. Like with, if they give you a center and the radius and diameter, you're going to have to go ahead and create the equation of the circle yourself. So we know that the equation of the circle is x minus h, y minus k. So if my center, this right here, is my h, and that's my k. So all you got to do is plug that into the formula. So the radius, so the equation of the circle is going to be x minus, and if it's -1, right? Because you got to plug a -1 into this. Two negatives will turn that to a positive. So it's x minus -1 squared plus y minus and then 7 squared is equal to, and then remember what's after the equal sign is the radius squared. Okay, so let me go ahead and clean that up a little bit. Let's do x plus 1 squared plus y minus 7 squared is equal to, and then 14 squared, I think it's 196, but I'm going to double check. 14 squared is 196. Okay, and that's it. That's the equation of your circle. All right. Well, the video got a little discolored there. All right. So that's one of the ways that that the FSA can possibly ask you how to use the equation of a circle, or the standard form equation of a circle. Another way would be if they give you a graph. So if you're given a graph, you're just going to go ahead and figure out, okay, well, from here, how am I going to create my equation of the circle? So that's why I wanted to start with this example, just to show you that you only need two things. You need the center and you need the radius. So if I look at this circle right here, my center is located, this is my origin. My center is located 1, 2, 3 to the right, 1, 2 down. So my center is at 3, -2. Positive 3, -2, and that's my h and that's my k. All right, and then my radius is, let's see, so the radius is always the distance. I'm going to say that carefully because that's going to help us with the next example. It's the distance from the center to any point on the circle. I think the easiest one to count, or the countable radius, would be from here to there, like straight across. So from the center to there, we have 1, 2, 3, 4, 5. So my radius is 5. Okay, and that's it. We just got to plug it into our standard form equation. So it's going to be x minus h is there, squared, plus y minus -2 is like saying plus 2 squared, and that's equal to the radius squared, which we know that 5 squared is just going to be 25. Okay, pretty simple stuff. Okay, so like I said, you need two things for your equation. You need the center and you need the radius. But here, they gave you the center, so we got that. But the other thing is they gave you a random point on the circle. So, you know, the thing is, you can find any random point on the circle, but like, for example, let's say if on this problem, my other point was over there. It's not really a countable distance that you can just go ahead and say, oh, well, that's the radius, I'm going to square it, right? So what we would do here, right, is, like I said before, to find the radius of the circle, it really is just the distance between the center and any point on the circle. So if we want to know what the radius is for this example, right, I'm just going to do radius. That's going to be equal to the distance between center and that point, and that, like, this is specific point on the circle. So, you know, hopefully we go back to our distance formula. So we have the square root, and I'll think of this as like x1, y1, x2, y2, and we do that distance formula. So it's going to be x2 minus x1, so negative 7 minus 1 squared, plus y2, negative 13, minus y1, so minus negative 5 is like saying plus 5 squared, okay? So then we have this is equal to the square root of negative 8 squared is 64. And this becomes positive 8 squared, which is also 64. So then my radius is equal to the square root of 128. Now, I know some of you are probably rushing, because that's what we do when we watch these videos. We rush to do the math problem. But you're probably rushing to go ahead and get the square root and get your decimal value for this, or maybe even simplifying the radical if you've gotten that far in your class. That's actually not going to be necessary for this, because you got to remember that this is just a single r, right? So I'll show you exactly why we don't need to go through all of that. So what we're going to do is we're going to go ahead and set up our equation. So we have x minus h. Why did I put h? Sorry. Let me start here. It's going to be x minus 1 squared plus y minus k is negative 5. So that's going to be plus 5 squared. And then that's going to be equal to, and the reason why we don't have to go through setting this as a decimal and just leaving the radical there is because r squared is going to be this whole thing, right? 128, the square root of 128 squared. And if you square a square root, that's just going to leave you with the number that's on the inside. So really the final equation is just going to be x minus 1 squared plus y plus 5. Man, my handwriting's awful. 5 squared. And that's equal to square root of 28 squared is just going to be 128. Okay, so not too bad, pretty straightforward. So again, just, you know, if you know that your radius is a square root of a number, just leave it alone. And then when you actually put it into your equation, you could just get rid of the square root, and that'll make it easy. So why can't I turn? Here we go. All right, so we have a few more examples. All right, so for example 4, what do you do if you're given the center and the circumference slash area? Okay, so we made sure to cover one of each example. Hopefully, you guys remember that the circumference equation is equal to either 2 pi r or pi times d, right? And the area of a circle is just equal to pi r squared. All right, so if you're given that, really the only reason why we would need to know these formulas if they give us this information is because, again, we're given the center, check, but we also need the radius, okay? And if they give us a circumference, we can use this in our circumference formula to figure out what the radius is. So this is going to be pretty straightforward. So I'm just going to rewrite the formula. C is equal to 2 pi r, right? So I'm just going to, again, the radius is what I ultimately need from this. So I'm going to go ahead and plug in my, if I know that my circumference is 17 pi, I'm going to put 17 pi in for C. And then is equal to 2 pi. We don't know our radius. That's what we're trying to find out. So if I want to get radius by itself, I'm going to go ahead and divide both sides by 2 pi, right? So that cancels with that. Luckily, the pi's cancel with each other. So now I just have pi, 17 divided by 2 is my radius. So ultimately, I know that my radius is 17 divided by 2, or 8.5. Okay? So perfect. I've got my center, I've got my radius. Now it's just plugging it into the formula. So I have x minus h, so it's h and k. X minus h is 9 squared plus, and then I have y minus my k, which is 12 squared, and that's equal to 8.5 squared. All right. And I guess to make it a little bit nicer, I could probably start getting straight ahead. I think you understand that it's the radius squared. I'm just going through that extra effort to make sure that you guys get in that habit. Plus y minus 12 squared. And then 8.5 squared is 72.25. Okay. All right. So that's it. Moving along. Same thing over here. This time they gave you the area, so you got to make sure you remember that area formula. We know that area is equal to pi r squared. So when I go ahead, I can plug in 361 pi into this. So 361 pi, that's my area, and that's going to be equal to pi r squared. All right. Now, what I'm going to do here, again, the goal is to get r by itself, right? So I can divide both sides by pi. But, I mean, let me ask you this. Well, you can't answer, but let me ask myself this. If I have r squared by itself right here, so I know that r squared is equal to 361, it's not really necessary to take the square root of both sides, kind of like before. It's not really necessary to, actually figure out the decimal version of that square root, because at the end of the day, it has to be equal to r squared anyways. So I'm just going to leave it like that. Just make sure you keep that in mind and you still recognize that in the equation, it's r squared. That's always the number one mistake that I've noticed with students in the past. All right. So again, it's going to be for the equation of a circle, it's x minus h2 squared plus y minus negative 2 is plus 2 squared. And then that's equal to r squared, which we know is just 361. Okay, something kids will always do is they'll probably square the 361 or whatever, but all right. Now, finally, for example 6, I'm really happy that this is a shorter video than some of my previous ones, but this time you have to look at an equation and then figure out the center and the diameter on your own. Keep in mind, it says diameter. Read the problem, guys. All right, so if I look at this, I'm going to go ahead and when I look at x squared, right? I know that we're used to seeing x minus h squared, but this is pretty much the same thing as x minus 0 squared, right? Because I mean, anything minus 0 is just itself, right? So just keep that in mind. If you ever see an x squared term by itself or a y squared term by itself, then that means that either h or k respectively is going to be 0. And then the other thing we got to point out here is this is going to be r squared. Okay, so please, again, whenever you see this number, it's that this number on the right side of the equation is not r, it's this r squared. So when I look at my center is simply going to be 0 for my h. And the other thing to look out for here, it says y plus 10 squared. Please do not put a positive 10 as your k. All right, you got to remember the standard form of a circle, it's y minus k. So in order for that to even be a plus sign inside of the equation, that means that the 10 had to have been negative. Okay, and then of course the radius is simply going to be, so I'm going to go ahead and do that work here on the side. So I know that r squared is equal to 42.25, square root both sides to figure out that my radius, go ahead and do that here. The square root of 42.25 is 6.5. Okay, and while it's nice having the radius, right, they weren't asking for that. They were asking for the diameter. So if you're doing your problem sets or if you ever see this question on the FSA, please make sure that you multiply this by 2. So 6.5 times 2 is 13. So I got my center and my radius, or my diameter right there. So hopefully that was a pretty straightforward lesson. If you have any questions, of course, you can always ask any of us and we will do our best to help you. But I think this problem set will be pretty easy for you guys. All right, take care. Good luck. Have a good week.